Action.
Good afternoon, ladies and gentlemen. This is Ray Dussault with CTC and 2020, and we're going to go over a review on bridge circuits. Now, the thing with bridge circuits we've got to remember is Gustav Kirchhoff. We use him so much it's not funny. All right, let's start with the bridge circuit here. Let's got a polarity. We got a negative polarity here and a positive polarity there, right? So that's going to indicate a current flow in each of the resistors. It goes from negative to positive, like this. It's very important we, at first, get familiar with how we get these things going the right way, because any voltage, Gustav Kirchhoff says, any voltage drop in a circuit is the algebraic sum of zero, which means the sum of the voltage drops has to equal the sum of the voltage rises in any closed loop in any electrical circuit on Earth. Now let's go from here. 120 volt source, we've got 90 ohms and 30 ohms. I see I'm on question 4, but that's okay. All right, we've got 90 ohms and 30 ohms. I've got 120 ohms, 120 volts. I've got 1 amp of current there. Okay, in that branch, heading up that way. 1 amp of current across 30 ohms of resistance creates a voltage drop of 30 volts. 1 amp comes up through here. This is just a potential measuring, like a voltmeter. Does have nowhere to go, it goes through 90. So 1 amp across 90 ohms gives me 90 volts. Okay? So let's go back over here. We've got a parallel branch. If we follow the branches out here, we'll see we've got 120 volts over these two combined resistances. These two combined resistances equal 120 ohms also, so that means 1 amp up this branch. 1 amp across 80 ohms gives me 80 volts drop on the first one, and it gives me 40 volt, 1 amp over 40 ohms gives me 40 volt drop there. Now, let's start answering a few questions to do with this, right? So let's look at this resistor. Let's call this resistor A. Let's call this resistor B. Now, this is negative. Coming up off negative, I'm 30 volts. Negative. 30 volts. That's how high off negative I am. Coming up off negative over resistor B, I'm 80 volts. Off negative. So therefore, we can say, because we've got to remember, at the end of resistor A is point A. Point A is closer to negative than point B. Therefore, A is negative with respect to B. If we were to put a resistor in there, we would get current flowing from A to B. Okay? Now, let's do a voltage drop. We want to know the voltage between the gap here, A and B. This one comes up 30, this one comes up 80. The difference between 80 and 30 is 50 volts, with A being negative. Now, if we follow this through to its logical conclusion, any closed loop, 30, right, plus 90 is 120. 30 plus 50 is 80, plus 40 is 120. 80 minus 50, because we're going back against it, plus 90 is 120. I don't care which way you go around in that loop, it'll algebraically equal 0. So that's how to solve that bridge circuit. Thank you.